Welcome back to another Ford's College Explainer. Now, as we continue our journey through applied Solidity development, specifically focusing on building token sale mechanics, we finally arrived at the refund and post-sale management phase. If you followed our previous lesson on designing a project-specific pre-deployment plan, well, your token sale mechanics should be absolutely locked and loaded. But today, we're tackling the final boss of your token sale, the post-sale audit. So picture this. The sale is totally over, the dust is settled, you're feeling pretty good, and suddenly, a wildly panicking compliance officer bursts into your office. Their burning question, where did that refund actually go? You can kind of think of this explainer as a bit of a detective mystery. As a developer, it's on you to prove exactly what happened to those funds. We're going to trace every single digital footprint to reassure those stressed-out compliance and accounting teams.
All right, to crack this case, here is our engineering blueprint. We'll start with the audit panic, then look at 3 vital sources, real-world reconciliation, the contract schema, building the report, and finally, exceptions and the final verdict.
Okay, jumping right into part 1, the audit panic, verifying outcomes.
So, the token sale's finished, refunds are processed, but now you have to rigorously answer to the accounting teams, and they need hard, verifiable evidence. But listen, a post-sale audit isn't just some dry, boring accounting chore. It is a reproducible aggregation process that directly links on-chain events to off-chain receipts and human approvals. Really, it's the ultimate ledger of truth, proving beyond a shadow of a doubt that your smart contract actions were entirely legitimate.
Moving right along to part 2, 3 vital sources, data for audits.
To build a completely airtight case for compliance, we need to introduce our prime suspects, or our data sources. We have on-chain events, which give us those beautiful immutable anchors like the transaction hash. Then we have payment receipts, evidencing actual real-world fund movement. And finally, internal logs, which show the human approvals. Mechanically, you've got to treat these as joinable tables. The whole goal here is to find canonical identifiers, like the all-important sale ID, that perfectly thread through all 3 of these sources.
And honestly, this highlights a core principle of Web3 development, the strict separation of data. We literally must maintain a hard, uncrossable line between our public, immutable anchors on-chain and our off-chain data, which, remember, contains highly sensitive fiat receipts and human approvals. This pattern perfectly balances total, verifiable transparency with strict user privacy. It's the best of both worlds.
All right, section 3, real-world reconciliation. Real-world scenarios.
Theory is fantastic, sure, but let's look at a hypothetical Friday afternoon scenario. Just imagine you operated a massively successful token sale and you now have 12,000 pristine purchases to dig through. Sounds great, right?
Well, you also had to process 420 refunds, and every single one of those 420 refunds needs to be seamlessly reconciled across our 3 data sources. That means accurately mapping the on-chain event to the payment provider receipt to the internal approval log without dropping a single digit.
Which brings us to section 4, contract schema, Solidity event design. Now, we are definitely not going to solve this mystery by manually checking 420 transactions. No way. Instead, we draft our first blueprint, a minimal, highly efficient Solidity event schema named refund processed. Our schema fields are indexed sale ID, indexed beneficiary, amount way, currency, and off-chain receipt ID. By indexing the sale ID and beneficiary fields, our script can quickly filter logs later. It's an absolute lifesaver for your querying performance.
But I want to focus on that off-chain receipt ID. This is a seriously brilliant engineering trick. It's a compact bytes32 hash pointing directly to a receipt. You see, by storing just a hash, you keep that sensitive fiat payment info completely off the public ledger, but you still maintain an explicit, cryptographically verifiable link to the off-chain data. It is elegant, and more importantly, it is secure.
On to section 5, building the report, aggregation script.
Okay, time to wire the whole shebang together. We're going to use a Node.js aggregation script to output a beautiful, defensible CSV report. The data flow is simple. Step 1, query those refund processed events. 2, fetch the payment receipt from your API provider. 3, join them together using that clever off-chain receipt ID we just talked about. And 4, write the combined data to a CSV. And hey, massive pro tip here. Always query your events using block-based windows rather than time-based windows. That ensures your audit is perfectly reproducible.
Finally, section 6, Exceptions and verdict. Handling mismatches.
So, you run the script, the case seems closed, but just as you're about to hit send to the compliance team, we hit a dramatic plot twist. What happens when there's an on-chain event but absolutely no off-chain receipt? For instance, what if a purchaser was refunded wholly on-chain using stablecoins, bypassing the fiat provider entirely? Well, your script is going to show a missing receipt.
First of all, do not panic. This is exactly where you use an on-chain only indicator. The reality is, discrepancies are totally expected in the real world. You got to treat exception handling and manual reconciliation as first-class audit data. Explicitly recording why an off-chain receipt doesn't exist, or logging the specific manual reconciliation steps you took, that is exactly what external auditors want to see. It shows you're actually paying attention. So, bringing it all together, here is your final deliverable, the complete audit package. 1. The reconciled CSV, which is your core data. 2. The attachments, meaning your raw receipts and internal logs. And 3. The methodology note, the narrative explaining your query windows and any manual steps taken. Hand this package over, and I promise you will make your finance and legal teams weep tears of absolute joy. You did it. You solved the mystery.
Let's wrap up today with this final thought. Without explicit links, reconciliation devolves into time-consuming manual work. Are your smart contracts truly auditable? Keep that provocative question in mind as you prepare for our next lesson, which dives into legal compliance, customer trust, and final considerations. Thank you so much for watching this Forge College Explainer. Remember, to master Web3 development and dive deeper into this curriculum, be sure to visit forge.college. See you in the next Explainer.